Assalamu alaikum. Myself, Dr. Ansari Farzana, Veduzama, Department of Chemistry, J.A.T.rts Science and Commerce College for Women. Welcome all of you. In previous section, we have seen about the solution definition and mode of expressing the concentration and the Raoult's law for ideal solution. The chemical potential of component in binary mixture is given by the equation mu A is equal to mu A star plus RT ln Na, mu B is equal to mu B star plus RT ln Nb. Here the term L is omitted because the case liquid-liquid mixture is considered mu A, mu B. Represent the chemical potential of A and B in the mixture. Mu A star and mu B star are the chemical potential of pure component. Na and Nb denote the mole fraction of the component A and B in the mixture. Gives energy of mixing of ideal gases. Consider a liquid mixture of two components A and B with Na moles of A and Nb moles of B. Total gives energy of system before mixing is given as Gi is equal to Na mu A star plus Nb mu B star. After mixing the pure liquid, chemical potential of the component is given by the mixture Gf is equal to Na mu A plus Nb mu B. Substituting equation 1 and 2 in the substituting equation 1 in equation 2, we got Gf is equal to Na mu star A plus RT ln A plus Nb mu star B plus RT ln Nb. The Gibbs energy of mixing will be G is equal to Gf minus Gi. Delta G mixing is equal to Na RT ln Na. Gf क्या है हमारा Na RT ln Na plus Gi क्या है Nb RT ln Nb. Using mole fraction N is equal to Na upon total number of mole and Nb is equal to Nb upon total number of mole, where N is equal to mole fraction of A and mole fraction of B. Substituting in equation 2.15, it becomes delta G mixing is equal to nRT Na ln Na plus Nb ln Nb. Since mole fraction are less than 1, delta G mixing is negative for all composition, therefore mixing is spontaneous. Entropy of mixing. It is known that diva G upon diva T is equal to minus S. Therefore, delta S mixing is equal to delta G mixing upon diva T at constant pressure. Therefore, delta S mixing is equal to minus NR Na ln Na plus Nb ln Nb. It is obvious that delta S mixing is greater than 0. Enthalpy of mixing using delta G is equal to delta H minus T delta S as per definition of Gibbs free energy. Delta G is equal to delta H minus T delta S. Then and equation 2.16 and 2.17. See here 2.615 and 2.16 and 2.17. It is the 2.17. delta H mixing is equal to 0. Delta V of mixing is given as delta G upon delta P at constant temperature is equal to V. Therefore, delta G upon delta P at constant temperature is equal to delta V mixing, and this is equal to 0 as delta G is independent on P. A graph of delta S mixing, delta G mixing and delta H mixing. This figure shows the variation of changes in Gibbs free energy, entropy and enthalpy of mixing of two liquids forming an ideal solution with composition. In a solution consisting mixture of two liquids A and B, there are three types of interaction: AA interaction, BB interaction and AB interaction. Ideal solution. In case of ideal solution, there are interactions between molecule of solution unlike that of ideal gas where molecular interaction is zero. In ideal solution, A-B interaction are equal to strength to those of AA, BB, A and B molecule mix randomly and the homogeneous solution result. The properties of such solution can generally be predicted from the properties of pure component. There is no overall enthalpy change and volume change in the formation of an ideal solution from its pure component. Many mixture of liquid hydrocarbons show this type of behavior. For example, carbon tetrachloride and cyclohexane, benzene and toluene mixture. This type of solution obey Raoult's law where solute as well as solvent obey Raoult's law at all composition and temperature. For component A and B, PA is equal to Na PA star and PB is equal to NB PB star, where Na and Nb are the mole fraction of component A and B respectively in the solution. Pa star and Pb star are the vapor pressure of pure component A and B respectively. Vapor pressure of ideal solution. Consider according to Dalton's law, Pa is equal to Pa plus Pb. Pa is equal to Na Pa star and Pb is equal to Nb Pb star. Since mole fraction Na plus Nb is equal to 1, rearranging this equation, Na is equal to 1 minus Nb. So, the above equation can be written as P is equal to 1 minus Nb Pa star plus Nb Pb star. Now, rearranging the equation, it becomes Pa star minus Pb, Pa star into 1. Here, this is the bracket term. Pa star into 1 is equal to Pa star and Pa star into Nb is equal to Pb star. Therefore, it becomes Pa star minus Nb plus Nb Pb star. And this is equal to, rearranging this equation, it becomes Pa star plus Nb Pb star minus Pa star. Or this equation can also be written as P is equal to Pb star minus Pa star Nb plus Pa star. At a particular temperature, Pa star and Pb star are constant and plot of P versus Nb should be a straight line with slope equal to PB star minus PA star and the intercept equal to PA star at NB is equal to 0. See this figure. This is the total and partial vapor pressure of ideal solution at constant temperature. The dotted line represent partial vapor pressure of A and B, that means PA and PB are given by the equation. The solid line represent the total vapor pressure of P and the total vapor pressure at all intermediate concentration can be obtained by taking the sum of partial pressure of two components corresponding to the particular concentration. Thus, at Na is Np is equal to, therefore P is equal to Pa plus Pb. If the system is of ideal solution, then Raoult's law is applicable and one will get plot as shown in this figure. But in general, for non-ideal solution, Raoult's law fails. Naturally, this type of graph will not be obtained for non-ideal solution. However, it has been found that a few binary solutions, for example, benzene, toluene, ethylene bromide, ethylene chloride, N-hexane, N-heptane, carbon tetrachloride, silicon, tetrachloride, water, methyl alcohol, N-butyl chloride, N-butyl bromide, etc. Behavior of such solutions are attributed to their chemical similarity, thus indicating that intermolecular interaction in such solutions are uniform. Thank you for watching.